In this lesson, we will learn how to solve questions like the one shown here, where we want to find the units digit of a large power. Now, as you can imagine, 19 to the power of 42 evaluates to be a very large number, so we certainly do not want to perform these kinds of calculations. Instead, we are going to look for a pattern in the various powers of 19. To begin, 19 to the power of 1 is equal to 19, so the units digit here is 9. What about 19 squared? Well, to determine this, let's go over here. First, we have 9 times 9, which is 81, so we will place a 1 here and then carry the 8. At this point, we could multiply 9 and 1, but we really don't need to. Here's why. Notice that before we multiply 9 and 1 here, we first add a 0 to our calculations. At this point, it doesn't really matter how the rest of our calculations go, since we are only interested in the units digit here. Notice that when we add our two products, the units digit is 1 and the remaining digits are unimportant to solving the question. So all we need to know when we evaluate 19 squared is that the units digit is 1. Now what about 19 cubed? Well, first we should recognize that 19 cubed is equal to 19 squared times 19 to the power of 1. Now we just determined that 19 squared looks something like this, where the units digit is 1, and 19 to the power of 1 is equal to 19. So we want to find the units digit of this product. When we multiply 9 times 1, we get 9. From here, the remaining calculations are unimportant because before we multiply 1 by any numbers up top, we must first add this 0. As such, the remaining calculations have no effect on the outcome when we add these results. As we can see, the units digit of 19 cubed is 9, so let's add this over here. Now notice that the units digit of 19 to the power of 1 is 9, and the units digit of 19 cubed is also 9. Once we see that a units digit is repeated, the pattern will continue like this forever. Now in this example, we have two different units digits before the pattern begins repeating itself. So we say that the pattern has a cycle of 2. So continuing with the pattern, the units digit of 19 to the power of 4 will be 1, the units digit of 19 to the power of 5 will be 9, the units digit of 19 to the power of 6 will be 1, and so on. Now one way to look at this is to say that when the exponent is even, the power of 19 will have units digit 1. But we want to develop a strategy that handles other cases where the cycle is not 2. So another way to describe this pattern is to say that when n is divisible by 2, the cycle, then the units digit of 19 to the power of n will be 1. Since our goal here is to find the units digit of 19 to the power of 42, we can see that since 42 is divisible by 2, the units digit must be 1. So that's how we solve questions where we are required to find the units digit of a power. First, find the units digits of different powers until you determine the cycle. Once you know the cycle, you can make conclusions about the units digits of other powers.